Hello everyone, welcome to this online classes for class 11th or JEE mains. This is my second lecture on the sets. Today our topic is empty set. Okay, as you know, if we consider a set A in a roster form, if set A is the collection of all x such that x is a student presently studying in the class 11th. Okay, it means if we can go the school and we can count the number of students which presently studying in that particular school, then obviously it is a natural number. Okay, next we suppose another set B where B is the collection of all x such that x is a student presently studying in the both classes 10th and 11th. If we observe the second set which is given in roster form, then we will find that it is impossible for a student which study in the both of the classes simultaneously in class 10 and 11. So it means in set B the number of a student is not in natural number, right? Here we comes to the definition of empty set. It means a set which does not contain any element is called empty set. Empty set is also known as null set or void set. Empty set, null set, void set, all are synonymous word. Okay, so we can give other examples of empty set like this. Suppose another set W where W is the collection of all x such that x is an even prime number greater than 2. Second, collection of all x such that x square minus 2 is equal to 0, where x is a rational number Next example, suppose x, collection of all x such that x square minus 4 is equal to 0, where x is irrational. If we observe all these examples of set one by one, then here we find that if there is no even prime number except 2, so there is no any element exist in the set W. Similarly, if we observe set x, here x square minus 2 equal to 0, it means x equal to plus minus root under 2. As we know that root under 2 is irrational, but here given that x is rational, that means set x also has no any element. Similarly, if we observe set y, x square minus 4 equal to 0, it means x equal to plus minus 2. Here x is irrational, which is not possible because we know that plus 2 minus 2 are rational, not irrational. Okay, first you write down these examples. Now our next topic is finite and infinite sets. Finite and infinite sets. First of all, to explaining this topic, we take some examples of sets. Suppose A is a set in which the number of elements are 1, 2, 3, 4, 5. We take another set B of alphabet A, B, C, D, E and F. Again we take a set C where it is the numbers of men presently living in the different part of the world. Okay, when we observe these sets one by one, then the number of elements in set A is 5. Here we also show number of elements symbolically like this. Na is equal to 1, 2, 3, 4, 5. Numbers of element in set B is 1, 2, 3, 4, 5, 6. So NB is equal to 3, 3, 6. Then what about the number of element in the set C? Is it possible to count the number of element present in the set C? It is not impossible. It must be a natural number, but quite a big. Okay, so we can count the number of element of the set C. So the number of element in C is also a finite number. It means C is also non-empty finite set. Okay, so here we found that set A, set B, set C all are non-empty finite sets. Okay, then we comes to the definition of finite and infinite set is the set of empty or non-empty finite set called finite set. In other words, a set which is either empty or consists the numbers of element, finite number of element, are called finite set. Otherwise, it is infinite set. Write down this definition. Now I give you some examples of finite or infinite set. Examples of finite or infinite sets. Suppose W be a set where collection of all x, where x is a day of a week. We know that there are 7 days in a week, so it is a finite set. Suppose S is a set of x such that x is a solution of an equation x square minus 5x plus 6 equal to 0. Okay. As we know that when we solve this equation, then there are two values of x, which is also known as the solution of this equation, which is 2 and 3. So there are two elements in set. This, suppose G is a set of all x such that x is a point on a line L. As we know that a line consists of infinite numbers of points, so there is infinite number of solution of the set G. It means set A is finite, set S is finite, and set G is the example of infinite set. Okay. If we have to represent any empty set, then empty set can be represented symbolically like this, phi or only the brackets. Okay. These are the symbols of empty set. But when we used to show a finite set in roster form, then we also use this bracket like A equal to 1, 2, 3, 4, 5, 6. Okay. These are the method to show a set in roster form in which all elements are separated by comma and all these elements are covered by the middle bracket. But how can we represent any infinite set like natural numbers? All natural numbers. If B is the set of all natural numbers, then we also use this bracket, but here we use dots, where dot tell us that the elements of the infinite set B is continuously moving up to the infinity. Okay. Now our next topic is equal sets. Suppose we have two sets A and B, like A equal to 1, 2, 3, 4, 5 and B equal to 2, 3, 4, 1, 5. Here we observe that A and B both have 5 elements, and all the elements, every element of A is also the element of B, and every element of B is also the element of A. So clearly here we found that A and B are equals when A and B both have exactly the same elements, right? So here we comes to the definition of equal set is like this. Two sets A and B are said to be equal if both have exactly the same elements, and we can show them as A equal to B. If A and B have not exactly the same element, it means if A has any element which not belongs to B, or B has any element which not belongs to A, then we can say that A and B both are not equal, and we symbolically represent this as A not equal to B. If both have not exactly the same element. Okay, that's all.